Hello, welcome back to the Periphery. Today we have another good one, Carl. We've got another good one.
Another great one.
This time with
Good at explaining things.
with one of my good friends from college, Ella. She is, kind of a legend.
I've known Afi for a long time now. We went to UCSD together, as he mentioned. Prior to me going to UCSD, I was in a unique position because, I kind of knew what I wanted to do, which is not common for a lot of people out of high school and isn't something that I shared with a lot of our peers at UCSD. And I'll just kind of expand upon that a little bit more. I could kind of pinpoint it to a particular moment. It was around my sophomore year of high school, and I'm from Baltimore, Maryland. I was, very happy with growing up in that environment. I thought it was a great space to be. There was a lot of other, kids in my neighborhood, had a lot of friends in high school, all of that great stuff. But I kind of felt like I wanted to challenge myself to be in an unfamiliar environment and just kind of thinking about the culture of California, the way that it's depicted in media, and also just, talking through my own network, like my parents' friends' kids that were older that had gone out to school in California and described the experience. It seemed like a place where innovation was very much encouraged and beyond just your immediate network. And I was very inspired by that concept because a lot of my peer groups, from the East Coast, tended to kind of, if they knew what they wanted to do, they would follow a path that was defined earlier. Either, they would join a family business, or they would go to a school where their parents had already gone, or they would follow, some sort of trajectory that was done before. And I wanted to kind of branch out beyond that, just because I felt that, based on my experiences up to that point, I did the best in uncertain environments. And so I kind of just thought about where I would want to be. And I realized it was California for the reasons I mentioned. I just identified with the culture. And in terms of my intellectual curiosities, I was really interested in a lot of the neuroscience research that was coming out of UCSD. And particularly in the cognitive science space, which is already very interdisciplinary, which gave me a great leg up into the tech space, which is where I am now. But, I started with neuroscience, and I was really interested in, from a biological standpoint, what determines, people, what makes people behave and act the way that they do? Is it something that can be actually scientifically quantified? And is neuroscience the right place to look for that? So I would keep up with a lot of the research. I started doing that around my sophomore year, and I remember
high school.
Yeah. And I remember
what? I'm sorry. What made you
Yeah, this is so unrelatable.
I know, it's really unrelatable. And the way that I got into the UCSD neuroscience papers was kind of relatable. It was from Tumblr. I would go on Tumblr, and those would come up on my feed, and I was like, oh, that's kind of interesting. It's not something that I can learn about in school, because there's no neuroscience classes in high school. I was taking biology, just normal high school classes. And I was like, this is really specific. And I like it because I can think about the concepts. And even if I don't understand them, because I'm not going to lie, I didn't understand a lot of the scientific context, but I could understand the problem spaces. So for example, if they were looking to represent I don't know, how do we trace anger from a neuroscience perspective? What are the origin centers of that sort of emotion? From a neuron level, what does the spiking of neurons do when you're angry versus when you're happy, and how can we measure that? And I was like, that's just kind of interesting from a modeling perspective. But I didn't want to go to med school, and I didn't really want to follow the research path. So I was interested in a lot of the concepts, but I didn't exactly feel like I had a best fit for what to do with those concepts that early on. But I was really lucky to kind of have that exposure to science, when I was young, and be able to do it independently, as I mentioned, because it kind of fueled my motivation to try really hard in school and get the grades needed to get into a UC from out of state. So I think that realizing at the very least that I wanted to go to California, and I wanted to be at UCSD specifically because they had a great research institution for cognitive science, allowed me to work really hard in high school so that I could eventually get there.
Can you list off? I was looking at your LinkedIn, and it's like such an interesting combination of undergrad like subjects that you either minored in, or can you like list those off?
Yeah, so my major is Bachelor of Science in Cognitive Science with a specialization in machine learning and computational neuroscience. And then I minored in math.
And I kind of want to start on the point of how much her career mirrors everything we want people to grasp from this like project we have here about her background. She has a very non-intuitive or non-traditional tech background, at least how she describes it. One, she chased the California dream from Maryland to California.
She did. She did. I mean, the way she was talking about California, I actually found quite refreshing. This is very much how I used to think about California before I actually moved to California. California always was this wonderland, not only just because of all of its geographic features, the mountains, the ocean, the sun, and just the complete package, really.
The people,
the skiing in Tahoe, and the beach at Carmel, and just the whole complete package.
Right.
But I feel like moving to California, I've clearly also recognized that this state is not perfect and that it has a lot of issues to deal with. And then I feel like the narrative in the media currently is that California might be past its prime. I'm not sure if I'm bought into this narrative, but I was reading today, for example, in the New York Times that I think California, for the first time, has like lost population, or that it's currently losing population, which I found quite interesting. So I guess, Afi, what I'm wondering is just, do you still believe that the California dream, is it still alive and well?
Oh, I'm going to say it's absolutely alive and well. But I do.
He's preparing for his political career.
No, I'm not. Okay, your point is well taken, though. When I first moved to California back in 2016, it took me, I think, 3 to 4 years to really start falling in love with California again. I think part of that was me leaving California again.
What do you mean again? So you moved, 2016, you had been there before as well?
No, or it took a while for me to start loving it at all. Or I guess, again, because I loved it the first month or two I was there.
Okay.
And then I was like learning more and more. I was like, this place isn't all that. You have to be kind of rich to really enjoy California.
I mean, the housing costs are off the charts.
It was $600 to $800 for a living room in La Jolla. But now I'm in love with the state. And I think what partially informed that was after undergrad, I spent 6 months, 8 months on the East Coast again. And I still believe the dream of kind of being forward-looking, trying to do things ahead of the curve, and being generally unafraid of the rebuffing traditions.
Yeah.
I think that's still very much alive here.
Yeah. So and even within the tech context more specifically, do you think California is still the engine of innovation that it used to be? I mean, in some ways, of course, it has been distributed more. You see other states starting to develop more of a tech scene, which is a good thing, right? We want innovation to not just be located at one hub. We want it to spread out to the periphery, right? Mm-hmm. But I'm just wondering, does California still have that front runner kind of carrying everyone on its shoulders status in the tech scene, where everything comes out of California?
You might have some people that disagree with that historical analysis, but
at least when it comes to the internet, right?
Well, I think that's right. I think we need to get clear what we mean by the periphery. Mm-hmm. Of course, I think I agree. It's great that we have more than one hub, but also I think part of no, I don't think we're quite as ahead of it as we used to be. We were having this conversation with August last night about how it was a recount on Apple and kind of how the history of how Apple became Apple today, especially with the transition to Tim Cook. And, my very rudimentary history understanding of Silicon Valley is that the periphery was genuinely involved. Designers were treated like CEOs. Flower children were kind of throwing things against the wall and seeing if it stuck. And I think that spirit's still kind of here, but I find that the value of being a bit eccentric and idiosyncratic. It's become, and August's gonna hate that I say this, much more like Wall Street, where it's just more traditional. Things. It's about profit maximization as opposed to building in a way that I think we've kind of lost a.
I mean, these companies have all become just very large,
So huge,
right?
yeah.
I disagree that there's no eccentricity whatsoever. I mean,
I didn't say that.
I think just if you're thinking about like NFTs and like Bored Apes, that seems kind of eccentric to me.
But that feels more LA.
Yeah, I mean, maybe. And I don't even know where most of the Web3 is happening. I don't know if Silicon Valley is dominant there as well. But no, I mean, your point is well taken, and we'll see, I guess, as California matures, as Silicon Valley matures, can it both kind of have these massive behemoth corporations that are dominant and maybe even maintain their dominance, but also keep kind of providing an environment where upstarts can also arise and maybe unseat one of these behemoths. I mean, we were talking yesterday about which one of the companies we would short.
I feel like we shouldn't disclose this. They're going to be our clients.
Yeah, no, we shouldn't talk about this on the podcast. But like, is it still possible to unseat one of these big monopolies? But we don't even have to. This is just a thought.
Especially, really. I mean, environment. Especially, with an environment that's crumbling around us and on fire every year.
Yeah. And we won't solve this today, but it's something worth thinking about.
Think about it. Sit on it. Ruminate. But to the point of like, who is the Periphery? Ella's story is exactly that. She was talking about how she had a very humanities background. She wasn't above average at math.
Again, how I got there, it's not like necessarily linear. Like, for example, when I was in high school and as I was just describing, I was into like neuroscience and like cognitive science research because I found it super interesting to try to relate that back to my own behavior and behaviors of others. I didn't like math at all at that time, and I wasn't even good at it. Like, I was not like an above average student by any regard in high school. Like, I took AP classes in the humanities, but I never took any AP STEM classes. And I was probably, I did not think that I could do it, for one. So it wasn't like, it was a confidence thing. And it was also like, just not what I was interested in, because when you're at a high school level, you're learning the foundations, right? You're not learning about the applications of things. And I didn't see the value, I guess, that young in those foundations. And I wish that I did, because when I went to UCSD, as you know, Afi, like I definitely struggled through those like engineering focused.
It didn't look like a struggle from over here to me. I mean, you worked hard though. You did work hard.
Yeah, I had to work really hard, but part of it was because I didn't like set up the strongest foundations in math, because I didn't think it was like necessarily something that I would be able to even do when I was in high school. So I was like, I'm super interested in all of these modeling concepts, but I'm scared of math. And I got to UCSD and I was taking the cognitive science classes, and machine learning would come up, and there's a whole component. So you can think of cognitive science as like a hybrid field that pulls from philosophy, linguistics, computer science, like mathematics and neuroscience. Very interdisciplinary. So even in your freshman year classes, you're learning bits and pieces of all of those things and how they fit together to study cognition. And so machine learning would come up, and I did not immediately think that that was going to be what I would ultimately do. It actually took a lot of encouragement from my classmates who kind of gave me resources. And one huge book that was very motivational to me my freshman year was On Intelligence by Jeff Hawkins. And that book basically—
I think August, our co-host, is not here. He mentions that book quite often.
It's a great book, and it basically walks that bridge between neuroscience and computer science, and how you can use math as a means to represent reality rather than, just something that you can do, which to that point was like all I thought of math. I was like, okay, yeah, like you do an equation, you get an answer, great, you turn that in, you get a grade, it's done. But my freshman year of college was the first time I started to realize like the actual applications of math as a tool to represent components of reality, which is aligned with all of those other fields in cognitive science that I had mentioned. What is linguistics? It's using language as a tool to represent our communication of components of reality. Neuroscience is studying like the biological brain that, constructs our reality to a certain extent. Like computer science is pretty similar to math in that it's like a technical representation of a problem space. And where does the problem space come from? It's like grounded in reality to a certain extent. So like when I thought about math just as a way to kind of like conceptualize certain components of reality and relate it back to my experience and my friend's experience, I wasn't scared of it anymore. I was little, but I still thought it would be worth it to learn. And that kind of intellectual curiosity like motivated me through all of the like academic failures and struggles, because there was definitely plenty of them.
And a lot of that had to do with the confidence that she felt, which I think, time and again, I feel like this point comes up with us in particular, but also so many of the guests that we've had on, especially those with more science backgrounds in this tech sphere, who are kind of doing cutting edge work. I mean, you heard Ella's resume. She's doing cutting edge stuff. She is, and it's that breadth of knowledge that's really contributing to that. It's not how good at calculus she was. It had nothing to do with really how good at calculus she was. Speaking of innovating in tech, she also told us why we want to have a general AI.
Yeah, I mean, she was describing to us how there have been different paradigms, maybe is the right word, in machine learning and in AI development overall. She was telling us very interesting things about symbolic AI that I'd never really, ruminated on in detail.
It seems like, for all intents and purposes, we're trying to get toward a generalized AI system. And I kind of want to ask about the tension in accomplishing that while we still have a really kind of rudimentary understanding of human cognition as a general matter. So we're trying to create something that we don't really quite even understand how it operates.
I think that's a huge blocker, to be honest. Like it's hard for me to conceive how we can represent something that we don't yet understand. I don't think intelligence is going to be like spontaneously created in an AI system. To me, that seems pretty improbable. Usually we have to, like as engineers, define motivations and intents to any system so that it actually produces the output that we require. I mean, if you think of intelligence as just like a way to solve a problem, like how a map can get you from point A to point B, if intelligence is just, solving a predetermined problem, you have to actually prescribe like motivations and intents to get it there maybe, but machines aren't just like spontaneously coming up with those. So I think that
within deep learning systems where they kind of like what's happening in those systems.
Within deep learning systems, they're spontaneously like creating new weights, which allows it to like reach convergence is the technical term. But essentially all that means is that it's looking at the training data and like understanding how a given output was created. And over time, it learns how to like optimize for that output. And the way that it gets there, the mathematical like path that it takes to get there is not always easy to trace, but it's not like it's not solving a problem that was outside of the domain of the training data, if that makes sense. So there's so many components just from a cognitive science perspective to like people, and so many motivations and desires that kind of drive us and allow us to make decisions. And I just don't think that intelligent systems like require all of them. For example, a lot of motivations for people like come from the fact that we are biological beings and we, evolved. And in order to evolve, you need to be competitive as an organism. A lot of your drives go back to like the need for shelter, hunger, water. And then as we become more advanced as a society, we have like egotistical drives, and we're motivated by other people and our peers and culture and cultural norms and values. And I kind of like beg the question, like, is it necessary for an intelligent AI system to have any of those things? I don't really necessarily think so. I think that AI will be most useful to people if we can allow it to, I just don't think that it needs to have any of those motivations. Like the motivations should be predetermined before, you train it or before you create it or release it. And I think it would be very difficult to like accidentally stumble upon a system that can solve like multiple things or can understand any of those things that we don't even yet understand ourselves. I think there's several hurdles. One of them is like for any learning problem, you need training data. And right now, those training data sets are also domain specific, which makes sense because usually you have a modeling problem and then you go out and either grab the data if it's open source and already exists somewhere on the internet, or you have to create it yourself. So like, where would you even start, right? Like if you have the task of creating a data set to model like a non-domain specific task, like let's say, I don't know, like if you look at a person, like we talk and we also, you know, think, and like we're doing all of these other sub processes, like we don't have data for that right now. So it's very hard to optimize an algorithm to do multiple tasks at once. Another thing would be compute. It's already very expensive to train machine learning algorithms to one task. So that would just scale up as you start to add more like larger data sets, which can capture more like facets of a problem. It would just cost more to train. And that's assuming that we're going to solve that problem with the existing tech stack that we currently use with using machine learning algorithms. There's also other fields of AI, which I think are really interesting, and they're not getting a lot of hype and press right now. Like symbolic AI is one. So that was very popular, like actually back in like the 70s and 80s. And it differs from machine learning in that you're not using very large data sets and optimizing them over one problem space. You're actually trying to define the problem space very concretely before training over it. So a great example of that would be like, let's say you want to create a language system, you would map out all of the components of language. So there would be things like syntax, semantics, and intention. And you would try to represent all of those components like concretely by like literally like tagging the language and creating a system that starts to make decisions that are predetermined over those tags. It's kind of similar. You can think like of to how you would like learn about language, right? Like you would learn what a verb is and what a noun is and how you put them together like little like puzzle pieces when you're first in English class. So that methodology was really popular back in the day and it had a lot of hype, just like machine learning currently does. But obviously like it never created like UAI or AGI, so it was kind of abandoned. And now there's been really amazing results with machine learning. So that's what's currently very popular.
What I found very interesting was just this idea of like domain-specific AI. In the popular imagination, we often think of maybe HAL in 2001: A Space Odyssey, or the one in Ex Machina,
or her.
Each one very
Her.
much.
Do you remember her?
Her, I didn't see that. I know what you're talking about.
Oh, you would love her.
Is it basically like an Alexa that becomes a human?
Yes.
Okay.
We should watch her together.
Okay. We will watch her and give you guys our review sometime soon.
Yeah.
But yeah, just in the popular media, it's often portrayed as this kind of human-like intelligence that very much acts like a human being and sometimes even has emotions like a human being. But what she was talking about is domain specificity, that today's artificial intelligence is not so much like a human being who can do a lot of different things. It's more that AI is domain specific and it can do one particular task, but it can do that much better than we do currently.
I think the most interesting part about that was how she was talking about how it doesn't even really matter that we get that far. Mm-hmm. You know, the effects and the outcomes and the fundamental shifts it can have in our society and how we all interact with each other, it's already there. And even she went even further to say how it's probably good that there'll always be a human somewhere in the loop of these AI systems dictating, you know, the goals and, you know, desires essentially of what these domains are actually, what the actual domain is.
Yeah. I mean, that part became strangely philosophical where we were talking about, humans are biological beings and
Yeah.
they have these drives and desires.
She did do cognitive science.
And that's what kind of drives them as individuals. And then we overlay on top of those biological desires and intelligence. And now suddenly, you have many more tools at your disposal to pursue those biological desires. And that's kind of how human intelligence maybe evolves. I'm not sure, but can also run rampant. But with an AI, it seems to me that what she was saying is that those biological desires are not built in like they are in this kind of intelligent machine that is a human being.
Like, and how could you?
We would have an easier time of defining the desires on behalf of, or the objectives on behalf of, the artificial intelligence.
Yeah, this kind of reminds me of a conversation August and I had about like just the enabling aspect of these systems. About August was like, how cool would it be if you had an AI that could like make the actors for you to move? Like basically AI is the movie, you write the screenplay. And I hated it.
Wait, you?
So like all you do is write the screenplay and you have an AI that can so advanced.
That makes the entire movie.
You can cast.
But at that point, the AI can write the screenplay too.
Well,
you can just be like, write me a movie about blah, blah, blah.
Well, I hated it. I was like, I kind of think like part of the like, and I'm not a director.
You hated the idea, or is there something that already exists like that?
It probably already exists in some respects, but all of it, all of it. I was like, I want the human interaction. I feel like that's part of the magic. And like the best movies, the actors had no small part in making that to life. But then he was like, well, the AI would just do exactly that and more.
Yeah,
I was like,
it's a very August take. But I mean, I think ultimately he's probably right. It's difficult. I mean.
No,
I do think there is room for AI to do unexpected and even beautiful things. I don't know how much you were following it was, what was it again? It was either the one that played chess against Garry Kasparov or the one that played AlphaGo against the South Korean Go champion. One of those two, I think it was the Go system that played against this South Korean champion. It made moves that like no one had ever seen before, and that were not only unintuitive and surprising, but so there was something almost kind of creative about it. And people who are in the know about Go almost said that this was like a godlike kind of move. And so I think there is that potential for artificial intelligence to do these kind of almost creative, artistic, unexpected things.
Kind of like within its own domains.
That's even within the human domain, just because it rearranges, or it thinks of things that we've never thought of.
With literally the benefit of having every thought possible within its system.
Yeah.
Which, kind of brings us to like another thing we were talking about with Ella, kind of the guiding principles for AI governance.
I think that there needs to be like better protocol around the deployment to production of machine learning systems, because I haven't really seen there being much beyond just retroactively like either notifying the consumer that this was an output from an AI system. So what, right? Like my question would be, okay, great, like you notify them, but how can they actually be informed about what that means and how that could affect them? And even prior to things going to the consumer, what can an engineer do to ensure that their model that they're going to release is going to be robust enough to handle, a data drift, for one? Like there is a responsibility of maintaining training data sets so that you're capturing changes as they happen in the world, specific to the model or specific to the problem that you are modeling. And I also just think there needs to be better and more clear accountability in terms of who's responsible for setting up, I guess, any like opportunities to catch outputs that are not congruent with the way that we want to make decisions in the real world. I think it's a hard problem because it's very hard to attribute blame. Like you want to assume that no one has ill intent. And a lot of times they probably don't. It's just that some of the like social and societal constructs that we're operating under are very, very hard to break down and put into just like a column of a training data set. You know what I mean? So we need to find ways to kind of either represent those things in the model itself so that the model can learn to, I guess, like ethically optimize them. And there's like research that has come out of Google where they've actually tried to do this. Like they've tried to capture some of the, first of all, they've looked at models that are creating outputs that could be harmful to particular groups of society without intending to be, just because of the nuance of, you know, as I had mentioned, like society and culture and like things that are not captured in the training data itself. Kind of like a weight to just realign the model to what human decision making would be, more closer to what human decision making would be, given that the person is informed about all of these other factors. That's really hard to do though, and it's really hard to scale, and it's not standard practice right now. So I don't think we can wait around for it to be standard practice to be able to like represent such complex like cultural phenomenons in training data. I think rather we just need to start with having more concrete measures that can be implemented right away, such as reviewing outputs over like diverse like input spaces before releasing anything to production. So what that would mean is like you should know where your model's going to go, like who's going to be interacting with the outputs. Like, can you get potential like input data that you can test to like look at production outputs and have a thorough like testing process, and then also keep track of who was collecting the training data and when and where did it come from, and then who designs the model and who's responsible for maintaining it. So I guess just kind of surfacing all of those things, I think, is a step in the right direction at least. Because I think there's a lot of value that we can get from machine learning systems. And I think it's very unfortunate that it does come down to like a modeling problem that we can't represent all of the possible confounding variables. But I think that that's not something that should deter us from leveraging machine learning solutions right now. I think we just need to have more transparency around how they come to be and like better, processes in place for improving them when something goes wrong, because it will, of course.
We have an episode forthcoming. We don't know when, but one of you all on the Periphery probed us to consider the intellectual property implications of AI systems that do exactly this type of work. Where does the copyright start and stop with an AI system that's making the art?
Yeah.
It's weird because it's going to infringe copyright to make its own work.
There are going to be so many different IP issues in that, and also
we didn't even get that far with Ella. We were kind of talking about.
Yeah.
We were like 10. We're still like at 2022 AI that we're kind of thinking about with the governing principles that she put forward.
And even think about. Actually, yeah, IP is going to be implicated in so many different ways, which makes me even happier that Afi and I, we paid so much attention in intellectual property.
Oh, we're not going to call me out right now.
Okay, maybe let's cut that.
No, I don't care.
But,
I don't care.
I said we.
You didn't say we.
I said we.
I outed myself. It's more about Dave. Dave's one who knows. He's taken patents classes.
Dave is the professional on this one. But either way, even with like deep fakes, even Barack Obama was talking about this, like not about the IP dimension, but
back when we had dinner with him last week, right?
After the talk.
Yeah.
The Periphery X Barack Obama annual dinner.
It's got to go through clearances, so it might take a few years for it to get out, but like, trust me, we did that.
Yeah. But, with deepfakes, like your person is being used and made to say things that you've never said, and often probably quite defamatory things. Mm-hmm. That's going to be an entire branch of law, I think. And that'll be really interesting. But no, coming back to laws that maybe are more important or more relevant to this particular episode are, as Ella was talking about, Asimov's 3 laws of robotics.
There is kind of a tension between what is popular like media and what is very entertaining for us to kind of consume as, consumers, and the actual reality of the technical engineering problem of AI. However, I look to science fiction a lot for guidelines and principles for, like from an ethical standpoint. And I think that's useful. So in the same way that I would go back and like read papers from the 70s and 80s from like the symbolic and theoretical space that never became popularized, because I think it's super interesting how they draw on, just they simplify very complex concepts in order to clearly define them, which machine learning does not do, right? So in machine learning, you create the training data and you create the algorithm that operates over that training data, and then you get the expected output because the training data contained hints at how to get there, essentially. However, in the symbolic space, it was much more like they didn't have that training data that had the expected output. They're actually going in and modeling the world. And I actually like have an example of it. It's of a science fiction laws that I think could apply really well to the creation of ethical like AI systems. And it's by like a book. It's from a book by Isaac Asimov. He's a science fiction writer. This is not really related to machine intelligence or AI, but it really stuck with me because I think the theory of the principles are like so beautifully straightforward and could apply super well. So it's a safety protocol for robotics. And the first protocol would be that a robot can't injure a human being through inaction or allow a human being to come to any harm. So the first protocol would essentially ensure that people can be safe in interactions with that robot. The second would be that a robot must obey orders given to it by human beings, except where these orders would conflict with the first law. So that kind of accommodates for the fact that we can't necessarily trust humans' intentions and human intelligence because there's a lot of, ill motive among society where people harm other people. So that would prevent a human from potentially being able to use a robot or a machine intelligence system to harm another. And then the third would be about the robot must protect its own existence as long as such protection does not conflict with the first or the second law. And I also think that that's a really interesting point as well, because it would prevent, machines from being easily like manipulated in a way. And I think that that's kind of important. So I was just this comes from another book by Jeff Hawkins where he pointed that out as, these are principles that were created in a creative space for entertainment through science fiction. However, they're kind of like good engineering guidelines in a way as well. So that kind of goes back to like machine learning and AI as a field being super interdisciplinary and also
reflecting
kind of a
on these
process,
laws,
because I feel like the space is really open to input from science fiction writers, philosophers,
for
any
me,
of that.
Intuitively, these laws make a lot of sense. A robot may not injure a human being, must obey orders except for, when that would result in injuring a human being, and the third being protecting its own existence unless it conflicts with the first or the second law. That makes a lot of sense to me, and I think that can be like a basic guiding, like a guiding framework. But when applying these principles, like how useful are they actually?
I mean, as someone who's worked at the Center for AI and Digital Policy, so I know a thing or two about these AI policies. They're incredibly useful. I think they're useful for two reasons. One, they kind of set the stage, maybe just for one main reason, but they really help get to the core of what's the problem and what we're concerned about. These are only 3 principles, but, thinking of the Council of Europe, they articulated 10 different principles that Ella touched on, about accountability, about maintenance, and it started very vague and high level. Just like, what are we actually concerned about here? And how do we start to build the contours in that? And so when talking with those values, now we're seeing an AI Act that might be coming out, the European Union's AI Act, and they have some specifics. They have, what's a high-risk system? What's a low-risk system? What does that actually mean? How do we build in accountability? How do we build in transparency? How do we build in privacy in these things? Even with the Council of Europe, their AI Act, that's more than likely we'll be a party to, United States an observer country. They started very abstract. It was like human in the loop at all times. Yeah. What does that mean? At what point does that attach? Right. And I think having the values at the outset is everything. When we talked to Jamil Jaffer, and he was talking about the First Amendment, and he kind of took a step back. He was like, where do we start? He was like, what is the First Amendment actually getting at? Yeah. And then he was able to work backward from there. He was like, okay, let's take a step back. These platforms are kind of doing something, in his view, different with speech than it used to. Yeah. So what is speech supposed to protect? And then from there, how do we get these platforms to conform with that as much as we can?
Yeah, and I mean, in pure length or word count, I think these laws are probably around the same length as the First Amendment.
Exactly.
So,
yeah. And it's a bunch of scholars. And
I mean, I'd have to go back and take another look, but that seems correct. Yeah, so I mean, I totally agree with the idea that you have to start somewhere, and that these law, and also I feel like these laws, these would actually be like pretty strict if you applied these in an uncompromising way. Like if you think, like, it seems to me that under these laws, no autonomous weapon would ever be allowed.
Yeah.
Right. And
yeah.
And
I think
so
that's kind of the goal of some of these laws.
Yeah, but for me, I guess what I wonder about is, how viable is it? Because you would need international agreement to have some kind of moratorium on these weapons. And that would have to be agreed upon between nations that are often quite hostile to one another, especially right now.
I think
of course, we are able to. We've had nuclear weapons agreements in the past. Those have never been completely watertight. Mm-hmm. But I think it's just difficult.
With autonomous weapons, I think the case is even easier to make than with nuclear weapons. Autonomous weapons, if you have a fleet of indiscriminately murderous, bots or drones that make a mistake and you can't turn that off, it doesn't matter who you're going for. You might end up killing yourself.
But I think even actually...
that's kind of the argument that's kind of being furthered with people looking for these bans and moratoriums, or at least, autonomous weapons. There's not even saying you can't use weapons that act automatically in some respect, but there needs to be an off switch. There needs to be a human in the loop at all times to make these decisions to correct for when they go wrong.
I do think under these laws, though, even that would not be enough, because, like under Asimov's principles, because if you say, must obey orders given it by human beings, except where such orders would conflict with the first law.
Yeah.
So, like, even when there is an off switch, or even when the human is main kind of in control, like, I guess it depends on how you define a robot.
And it also depends on how. One, he's not going to be the one writing a policy. But two, it also depends on what you mean by robot and also artificial intelligence. If there's, to your point of the generalities, it's really hard to nail down.
No, and I'd have to. This is from
iRobot.
The rules were introduced in his 1942 short story Runaround, and then also collected in. Oh, that was in a collection called iRobot. Okay. Okay. So I'm glad we talked about those. What else? Is there anything else we need to kind of close with?
I think we did it, Carl.
It raised a lot of very interesting questions, I think.
It really did.
And Ella was a very helpful guest in just being in explaining these things in very clear terms.
Yeah.
So I thought that was very helpful.
One more thing before we go. We are at the Periphery Podcast, basically everywhere. You can email us at theperipherypodcast@gmail.com. We also have a Patreon. Your support would mean everything. And this summer, we will start releasing this season's full interviews without all of our shenanigans, the video versions on our Patreon. So if you're interested in that and you want that type of content, we got you covered there. And we will talk to you. Oh my God.
We'll
talk to you next week.
After Afi burps.
We'll talk to you next week.